Now in this question, we want to find an expression for the left-hand side using our knowledge of combinations. Before we do so, let us remember what was meant by NCR. And I've used capital N here to distinguish it from the lowercase n used in the question. I hope you recall that what this meant was that suppose you have n available objects to choose from. And from amongst these n objects, you want to choose r objects, where r is obviously less than or equal to n. NCR would give you the total number of different ways this can be done. Now, suppose we still have n objects, capital N objects, but what we do is split them into two classes or two categories, where the number of objects in the first one is lowercase m, and this refers to the lowercase m in the question, and there are n available, lowercase n available objects in the second category. Altogether, you still have n objects that you want to choose from, and you still want to choose r objects. Now, this can be done, as you can see, in many ways. That is, the number of ways of choosing r objects from a total of capital N, in other words, m plus n objects, is given by m plus n CR. And as mentioned before, this can be done in many ways. For example, you could choose all of your r objects from the m category, in which case you have MCR. But what if you choose all but one of your r objects from the first category, and therefore you'd have to choose one more objects from the second category, the lowercase n category, to make up the total number of r objects that you want to choose? So this can be done in, well, the first category you can pick r minus 1 objects from it in m, c, r minus 1 ways. But again, to make up the total number of r objects that you want, you'd have to choose one from an available n objects in the second category. Now, this is clearly not the only way as well. You could choose r minus 2 of your r objects from the first category, and obviously have to choose 2 objects from the second category to make up the total of r objects that you still want to choose. So we have m c r minus 2 times nc2, and you could continue this pattern all the way through until you only choose one from the m category, which can be done in MC1 ways, and you would have to obviously choose r minus 1 from the second category of n objects. And the final case, which we are now adding as always, is the case where we don't choose any of our r objects from the m category, and we choose them all from the n category, and that is NCR. So using our knowledge of combinations, we can find, and we have done so, an expression for m plus n CR.